Now that you understand that a logical simple statement is a sentence that is either true or false, and a compound statement is a combination of simple statements connected with the words and, or, if then, or if and only if, the next question becomes, how do we tell when a compound statement is true or false? If each of the individual components of a compound statement has a truth value, that is, each simple statement in the context of a larger compound statement has a truth value, how do we determine the truth value of the compound statement? That's what truth tables are for. Truth tables allow us to explore all possible truth values of the simple statements and how they bear meaning on the truth value of the compound statement. So in section 3.3, we will build truth tables for the negation, conjunction, and disjunction. And then in section 3.4, we'll consider the conditional and biconditional. Let's begin with some basic truth tables. The negation is our simplest connective to judge. Here's the rule for the negation. The negation of a statement has the opposite truth value of the original statement. Now, that's something that you already knew. We learned that from the definition of the negation of a statement. Here's how we build a truth table for the negation. First, we're going to consider a simple statement P. It has two possible truth values. It is either true or false. We can use this to determine the truth value of the negation of the statement, not P. If P is true, then not P must be false. And if P is false, then not P must be true. So here we've explored the truth value of the negation in terms of truth values of the original simple statement, P. Now, that's the easiest truth table that we're going to build. Let's work on an example. Determine the truth value of the statement and its negation. Statement P is a Big Mac has 563 calories. Now, according to Google, this is a true statement. The negation, not P, is a Big Mac does not have 563 calories. Well, if P is true, then not P must be false. The negation, again, is the simplest truth values that we can explore. Next, let's consider the truth table for the conjunction. Let me remind you that a conjunction is two simple statements joined by an and. Remember, the hat symbol represents and. It sort of even looks like an A with a missing crossbar, if that helps you to remember. Here's the rule for the conjunction. A conjunction is true only when both components are true. Now hold that simple rule in your mind as we apply this to the truth table. The conjunction P and Q is composed of two simple statements, P and Q. We want to consider all possible combinations of truth values for those two statements together. So this particular truth table is going to have 4 rows. Now, anytime we have a 4-row truth table, we're going to build it the same way. In column 1, under P, I'm going to have 2 trues and 2 falses. And then in column Q, I'm going to alternate true or false. So we have true, false, true, false. Now, this actually gives us every possible combination of truth values between P and Q. Look at row 1. Both statements are true. Look at row 2. The first one is true, the second one is false. And we have just the opposite of that in row 3. And then finally, in row 4, both statements are false. So by building it in this systematic way, we've considered every possible truth value combination for the two simple statements P and Q that compose this compound statement P and Q. Now let me restate the rule. A conjunction is true only when both components are true. The connective and is a very strong connective. In order for it to be true, both components must be true. So let's look at row 1. In row 1, P is true and Q is true. That means that the conjunction P and Q is also true. The other 3 rows have a combination of truth values. Look at row 2. P is true, Q is false. Since both components are not true, then the conjunction P and Q is false. Now, if this seems a little bit abstract, hang in there, don't give up. We're going to look at an example to illustrate these truth values here in a minute. Let's again learn how to build this truth table and understand the rule. Row 3, P is false, Q is true. Since both components are not true, then the compound statement P and Q is false. And then finally, in row 4, both components P and Q are assumed to be false. Therefore, the compound statement P and Q is also false. This is the basic truth table for the conjunction. Now, make sure that you know how to build a 4-row truth table. Make sure that you understand the truth table for the conjunction. And keep in mind, this truth table can be summed up in this one rule. The only time that we get a true conjunction is when both original components are true. Now, here's an example to illustrate this. Your intuition will be a great guide in helping you to understand the truth value of a conjunction. Example 2, determine the truth value of the given statements. A, the sod poodles play baseball in Amarillo, and the bulls play hockey in Amarillo. Now, if you're not from Amarillo, the sod poodles are the Amarillo baseball team, so P happens to be true. The bulls are the Amarillo hockey team, so Q is also true. And notice they're joined by the word and, by the connective and. So because both components of this conjunction are true, then the compound statement is true. So if we say the sod poodles play baseball in Amarillo and the bulls play hockey in Amarillo, that compound statement is true. Let's look at the next example, B. Amarillo is in Texas and New York City is in California. Now, if you hear that, it pricks your ears and catches your attention because there's a contradiction there, right? It says Amarillo is in Texas. We can call that statement P. Statement P is true. Now, the second half of this compound statement, New York City is in California. Well, calling that statement Q, that is definitely a false statement. So these two statements are joined by the word and. So P is true and Q is false. That looks like this situation right here. The component on the left is true. The component on the right, or the second simple statement in that compound statement, is false. Therefore, the entire statement as a whole is false. And that makes sense when you just listen to that example with your ears and consider the truth value of that compound statement. So, in summary, a conjunction is true only when both components are true. Memorize that rule, memorize that truth table. Okay, let's see how this is related to the truth table for the disjunction. Let me remind you, a disjunction is two simple statements connected by the word or. So whereas conjunction goes with and, disjunction goes with or. This is a completely different connective, and the words and or are not interchangeable in math, whether you're talking about logic or probability. Here's the rule for the disjunction. A disjunction is false only when both components are false. Now, what I'm attempting to do with these rules is simply summarize the entire truth table that we're about to build here into one sentence that you can easily remember. Notice how this rule is different from the conjunction rule. In the conjunction rule, we were looking at the special case of when the conjunction is true, because that was really the only result that was different from the other rows. In the rule for the disjunction, we're looking at when is a disjunction false. Here's why. That's the only one that's going to be set apart in the truth table. Let's go ahead and build our truth table. So notice we're trying to determine the truth value of the statement P or Q. That's right here in the last column. So we're going to consider all possible combinations of truth values for the simple statements P and Q. So we do this in a systematic way. We're going to put 2 T's and 2 F's for the first column. And then in the second column, we're going to alternate true and false. And remember, this accomplishes every possible truth-value combination for the individual components of that compound statement. Now remember, the rule says a disjunction is false only when both components are false. So let's look at row 1. If P is true and Q is true, then the statement P or Q is also true. Row 2, if P is true and Q is false, well, the disjunction is still true. Row 3, if P is false and Q is true, the disjunction is still true. And then finally, row 4, both P and Q are false, therefore the disjunction is false. So again, if this feels a little bit abstract, we're going to look at an example here that will help to illustrate this meaning. For now, remember that the rule for the disjunction focuses on this one special case. That last result is the only one that's different from the other 4 rows. So if I can watch for that case, then I can remember every other situation a disjunction is true. So a disjunction is false only when both components are false. Another way to think of this in general, you could observe a disjunction is true when at least one component is true. Notice how that's different from the conjunction, right? The conjunction, which is a stronger connective, has to have both sides true in order to get a true result for the compound statement. Whereas a disjunction is going to be true when at least one component is true. Now, let's look at this example. Determine the truth value of the given statements. Example A, Christmas is on December 25th, or pigs can fly. Well, this is our connective. It's or. Christmas is on December 25th. We could call that statement P. Pigs can fly. We could call that statement Q. Now, let's observe the truth values of each of those simple statements. Statement P, Christmas is on December 25th. Well, that's true. Statement Q, pigs can fly. Well, that's false. So we have statement P is true, statement Q is false. That's at least one true. So the entire statement as a whole is true. Maybe you have a grandmother that talks like that, right? Christmas is on December 25th, or pigs can fly. That is a true statement. Now, if I change that connective from or to and, then the statement would be false. Because remember, a conjunction, an and statement, is only true if both components are true. Example B, pigs can fly, or the moon is made of cheese. Pigs can fly, let's call that statement P. Our connective here is or. The moon is made of cheese, we can call that statement Q. So I have a disjunction. Statement P, pigs can fly, well, that's false. Or the moon is made of cheese. Well, that's false too. So we're looking at this last condition. Since both sides of the disjunction are false, then the entire compound statement as a whole is false. Now, take some time to go back over and really let this sink in. This is building a foundation for the more complicated truth tables that we're going to build later on. So let's do a quick review. A negation is always going to have the opposite truth value of the original statement. A conjunction is true only when both components are true. Every other time it is false. And then for a disjunction is false only when both components are false. Every other time it is true. And another way to think about that, a disjunction is true when at least one component is true. So I hope that was helpful. Again, go over that, let that sink in, and we'll look at some more examples in the upcoming videos.